Electrodynamics Chapter 4 summary in just a few minutes. Here we go. So remember previously we looked at electric dipoles. So you can calculate the dipole moment and the electric potential due to a dipole and the electric field due to a dipole. So that's all cool. We define the polarization of material as a bulk property. It's the dipole moment per unit volume. And with that, we can write the potential in terms of the polarization instead of the dipole moment. Now, why does this all matter? So imagine that I have some material that's polarized for some reason or another, and so we have no net charge, but we have a charge separation. If you draw the polarization vectors as arrows instead of this, you can see that up here, we're going to get unpaired charges. Down here, we're going to get unpaired charges. So it makes a surface charge density because it's polarized. We can calculate that surface charge density as the polarization dot n hat, where n hat's the unit vector perpendicular to the material. Now, if I have some polarization like this that's radially outward, it diverges. You end up with unpaired negative charges in the interior. So a divergence of the polarization leads to a negative bound charge density. So we can calculate the bound charge bound charge density is negative the divergence of P. So again, what are we talking about? The difference between bound and unbound charges. So these are bound charges. The total charge on this is 0. If I went in here and added some extra charges on the surface, those are free charges. So we want to treat those two things separately. Bound charges and free charges separately. Now it all comes down to this. So this is Gauss's law. Gauss's law says that the divergence of epsilon naught times E, I moved the epsilon to the other side, is the sum of the bound and the free charge density. It's the same as Gauss's law, I just wrote it differently. And then we can replace the bound charge density with the negative, the gradient of the polarization. And this leads to us to write D as epsilon naught electric field plus the polarization, and we call that the displacement field. Why would we do that? Well, now we have this for Gauss's law. It is Gauss's law. The divergence of the displacement field is the free charges. So we can find this displacement field, not worry about the materials first, and then go back and worry about the materials later. If you want more details on this, I have a longer video, and depending on what platform you're going to find it. But if you look for my playlist or something like that, you can find the longer video of this. Talk to you later.